Welcome to lecture 4, which is on technical terms which we are using in the drone surveying. So, in this lecture, we are going to learn various technical terms which we are using in drone survey work and what is their meaning and importance, and also you will be familiar with these terms and their uses when you are doing drone survey or land mapping. Now, if we look at the term drone, so there are various nomenclature in the literature. All over the world, people have used different terminology. Somebody says this is the unmanned aerial vehicle UAV, which is again a very quite popular term, but other terms have also been used: unmanned air vehicle, unmanned aircraft vehicle, unmanned aerospace vehicle, uninhabited aircraft vehicle, unmanned airborne vehicle, unmanned autonomous vehicle, upper atmospheric vehicle, aerial robots. Aerial robot is also a very common term. So, there are different terms which have been used, but the meaning is almost same. We are talking of in layman language, we are talking of the drone technology. Now, if we look at the UAV and UAS, unmanned aerial systems. So, these two terminology are also used very frequently, and particularly if you see the UAS terminology, unmanned aerial systems, it has been used by Federal Aviation Administration FAA of the United States and the European Aviation Safety Agency, which is EASA, and Unmanned Aerial Vehicle System Association. So, these have used the term UAS very frequently. UAS in much broader term, it is that describes the entire system which enables the operation of the UAV system. So, UAV we will use for the drone system only, but when we are talking about the UAS, it consists of the UAV platform in addition to ground control station, communication, data link, piloting, sensing, flight planning and other critical components which are required for the operation of the drone. That is called a UAS. So, if we see the difference between the two, a broad difference between the two. So, UAV term we are using from the aircraft only, the drone system only, but UAS term we are using for the complete system which is required to fly the drone, to collect the data and to process the data and so on. There are many terminology. It is important to learn those technical terms before the start of the drone survey, so that we understand the drone fully. So, the first terminology here is the level surface, because we know that the ground surface is curved, as I told you in my previous lecture. It is not a flat, it is not a level surface, but we actually, when we are collecting the data for a small area, we consider that as a level surface, not the curved surface. So, a surface which is perpendicular to the direction of gravity at all point is called the level surface. This is the basic definition if we read any book on surveying. Now, if we have to define the level surface, we give the example of a water surface in a still lake. So, that water surface in a still lake will actually represent the level surface. Then we are also very frequently using the second term here, which is the datum. So, a level surface is used as a reference for computing the elevations of the other point with respect to this datum. So, it is also a level surface, and with respect to which we are computing the elevations of the other natural points and the cultural points on the ground. If we look at now this diagram, in this particular diagram there are 2 points, point A on the Earth surface and point B on the Earth surface. So, if we talk about the level line, so a line here is shown as the level line, and this line continuously, if I keep on joining at A and B at another point, that become the level surface on the ground. So, at point A we have a vertical line which is actually indicating the perpendicular to the horizontal line. Similarly, at a B also it is indicating that, and there is a datum here. So, this is a datum, vertical datum geoid, with respect to which we are finding out the elevation of any given point, elevation of A or elevation of B, or the difference in elevation between the point. So, these level surfaces and datums are important when we do some kind of a surveying work for data collection, because in third dimension this is playing very important role when we want to depict the surface of the earth in third dimension. Then the third term is mean sea level datum, and it is a very popular datum. People are very familiar. It has been used since a long time now. It defined the average height of the sea tides for all its stages during the high tide period, during the low tide period, and if we take the average of those tides. So, it is the mean tide heights which is found out after taking the observation for 19 years and taking the average. Now, this is a very important surface because our all previous survey work, maps and other data is available at mean sea level. Mean sea level has been considered as a datum, although it is a local datum. But nowadays we are using the term called WGS 84 datum, World Geodetic System datum, because all our systems which are using the GPS and providing the three-dimensional coordinates, the reference for this is WGS 84, and what we are getting in this three-dimensional coordinates in terms of the real world coordinates, which is called latitude, longitude and the height, and this is important for geodetic mapping, this is important for navigational mapping, etc. It represents the best global geodetic reference system for the earth. That is why world over this we are using this WGS 84 datum, and it is uses for practical application of the mapping, charting, positioning and navigation. So, in this diagram here now we will see what is mean sea level and what is the WGS 84. So, you can see here the topography of the earth on the top. So, the earth surface is undulating. So, that is why the topography on the top is actually undulating. But if you see the red line here, the red line here is indicating the geoid, which is the mean sea level, and our earlier maps they were based on the mean sea level if we read the height of various points or the contours. Now, if we keep a GPS on the earth surface and try to take the observations, our observations now are based on the ellipsoid, the green one. So, we are taking the observations now on the basis of the ellipsoid, again it is a mathematical surface. So, there is a relationship. If we look in this particular diagram, the capital H is equal to small h minus n. Somewhere it is negative, somewhere it is positive in the relationship. So, the diagram below is indicating the mean sea level, the geoid with the blue line, and it is also showing the WGS 84 datum with the red line. So, this is the difference. So, somewhere it is going up, somewhere it is going down. So, in the relationship when we are using h minus n, it could be h plus n or h minus n, as we can see in the diagram below. Now, the other terminology which we are using, and always there is a confusion between these terminology amongst the users: elevation, height and altitude. So, what is the basic difference between these three terminology? So, first one, elevation. It is the vertical distance of a point above a given datum. So, if we are taking a datum and we are measuring the vertical distance of that, that is called the elevation of that point. So, normally you find that when we are talking about the elevation of any point, we say elevation so many feet or meter above mean sea level, because mean sea level was the datum at that time. So, that means from mean sea level, this is the height of that particular point. And in the diagram also, you can see this is the top surface of the ground and this is the datum. So, this is the elevation of the point. The second terminology is the height. Height is the vertical distance of a point above the ground. Any object which has a certain height on the ground. For example, a tree, it could be a high-rise tower, a building. So, height of that is the vertical distance above the ground. If we see in this particular diagram, there is a tower here and this height of the tower above the ground is called the height. So, height of the aircraft is above the ground. So, there should not be any confusion between the height and the elevation. So, elevation is always with respect to datum and height is always with respect to the ground. The third terminology, which is similar, altitude. So, this is also very important parameter when we are flying the drone, because each drone we can fly to a certain altitude. So, both for the practical purpose and for the interest of flying safely and legally, there is a limit in many countries. And what is that limit? 400 feet or 120 meters you can fly at that altitude. So, once we know at what altitude we can fly the drone system, then we should know what is altitude. So, in the diagram also now, if I add the two together, the elevation and the height together, that becomes altitude. So, altitude is this parameter, which is the height of the aircraft above a datum, above, if the datum is mean sea level, above mean sea level. So, if I add elevation and height together, that becomes the altitude. Then another terminology which we are using in drone survey or any other kind of a survey, the benchmark. These are very important points because the ground is unknown to us and we have to determine the elevations of various points with respect to the datum. So, benchmark will give me the known elevation of that point. So, benchmark means that I know the elevation of this particular point above a given datum. So, this point is established by the different agencies in the different countries responsible for the surveying and mapping work. For example, in India, the benchmarks are established by Survey of India. So, these are normally kind of a metallic kind of a plate where values are engraved. So, these benchmarks are used as a reference point. We know the elevation of this particular point and we collect the data in the area where we can link our data with the benchmark and can find out the elevations of the unknown point. And that is why the benchmark is important, and we can have in our area more than one benchmark also, because the other benchmark we can actually use for cross checking. Then we are collecting point cloud data where we know the coordinates. So, these are the planimetric coordinates, the latitude and longitude. So, it is important actually to understand these two terms. So, latitude and longitude. What is latitude? It's a measurement of a location on the earth surface. And how we are measuring that location? We are measuring this location with respect to degree, minutes and seconds, and north or south of the equator. So, if you see the latitude here, this is the latitude. We are measuring north or south of the equator. This is the latitude of a particular point where a star is shown over here. So, we are measuring in degree, minutes and seconds, and we can convert these into the polar coordinates. Longitude. Longitude is a measurement of the location on the earth, again in degree, minutes and seconds, but in this case it is east or west of the prime meridian at Greenwich. Greenwich, it is an imaginary line, north-south line that passes through both geographical poles and the Greenwich, London, UK. So, in the diagram also, now you will see the longitude of this. With respect to this particular line, which is the Greenwich line, we are measuring this particular angle. So, this is the latitude. So, latitude and longitude, once we know of a point, that together define the real world planimetric coordinates of a place. We still do not know the z, we know x and y in terms of the latitude and longitude. So, we are using these real world coordinates nowadays for mapping purpose. Now, there is a term called 3D coordinates. So far we know only 2D coordinates. So, this is a 3D coordinate where we are defining the coordinates of a point as x, y and z. So, this will give me a very precise 3-dimensional location in the space of the point. So, this in real world coordinates, now this 3-dimensional coordinate I will express as latitude, longitude and elevation, the terminology which we have learned earlier. So, here you can see in the diagram also that for the particular point in 3-dimensional space, I have 3 values, 3-dimensional coordinates. Now, the next terminology is the ground control points. Now, these ground control points are playing very important role in any kind of surveying work, including drone survey, because I am using the data of known data. 3-dimensional coordinates are known for these ground control points, and I am using this data to extrapolate the coordinates of the other points in the area. So, these are those points whose 3-dimensional coordinates are already known to me. So, how do I know the 3-dimensional coordinates of these points? Either they have been supplied by the surveying agency in the country, the coordinates, or a separate survey has been done to establish the ground control points in the area to carry out the drone survey, so that we can cover a larger area, and these ground control points are also visible when we are doing the survey work from the drone. So, these points should be very accurate, because the accuracy of other points which I am extrapolating the coordinates would depend upon the accuracy of these ground control points. We can see in this particular diagram all those targets which are well distributed in the area. These are the ground control points. So, we have to be careful, very careful in selecting the ground control points, so that they are not hidden and they are visible when we are taking the images or data from the drone. Once we can locate these, we will use these ground control points to prepare the mosaic of the area to find out the 3-dimensional coordinates of the other unknown points. Then, when we fly the drone, these terminologies are to be known. One is the drag. So, drag is the force which acts opposite to the direction of the motion of the drone. So, here in this case I have shown a quadcopter. So, quadcopter will fly vertically up. So, drag force is the force which is opposite to the direction of the motion. So, you can see in this particular diagram, this is the opposite force, drag force is shown here, which is opposite to the lift. It is caused by the friction in the difference in the air pressure, which tends to slow down the flying aircraft. So, it will pull the aircraft down. The second terminology here is the thrust. So, thrust is a force which will be generated by the propellers of the multicopter. So, in the multicopter we have the propellers, and when these are moving, the force is generated to work against the aerodynamic drag, and it is the force that moves the aircraft in the direction of the motion. So, we can see here, this is the thrust which has been generated, and this thrust basically is responsible to create a lift, and that is how the aircraft or the drone system will go vertically up. The next terminology is the lift, very important terminology. So, lift is the force which will act at right angle to the direction of the motion of the drone through the air. So, in case of a quadcopter here, you can see that lift is shown here, it's because it will take vertically up the drone system. So, it is responsible for lifting the drone up in the air, acting against the weight of the drone. So, it is always more than the weight of the drone, and that is why the drone will actually lift up in the sky. It is created by the difference in the air pressure above and below the wings of the drones. The propellers on the multicopter generate a thrust lift force, and which is always greater than the weight of the drone for a successive flight. So, we have to actually see that the payloads which we are mounting, for example, the camera systems or the other sensors which are mounting on the drone, this should not be very heavy, otherwise the drone may not be lifted for a greater height. So, the dead load of the drone itself plus the payload has to be counted as the weight of the drone system here in order to consider the lift. Then another term here is the vertical takeoff and landing, and this is true in case of either the hybrid system or in case of the quadcopter system in rotor systems. So, short form is a VTOL. A VTOL aircraft is one that can take off and land vertically without requiring the runway. So, we are basically using the capabilities of the copters, rotary wing drone systems, and they will lift vertically up, and you do not require any runway to take off and landing. The example includes helicopter and rotary drones in this particular category. So, they are also called VTOL drones. Now, flight planning is very important, whether we are doing aircraft survey or whether we are doing the drone survey. This is very important because it is the process of creating an automated and semi-automated plan for a drone's flight to collect the specific data. So, whether we are flying toward the longest line of the area or towards the shortest side of the area, whether our flight is oriented north, south or east, west, that has to be actually planned before the drone is flown to the area. Nowadays, we are using the software. We are doing some planning on a Google Earth map or a large scale map. We are doing that particular planning, orient our area, see the extent of the area and how the drone system will move from one strip to the another strip. So, you can see here that in this particular diagram, the lines are shown. These lines are indicating the movement of the drone up in the air to cover the whole area. Okay. So, from a starting station, it will come to the first line and the second line, and these circles are indicating that it will take a turn to go to the second line, and then it will go to third line and the fourth line and so on it will complete the whole area. So, we are using the capabilities of the software nowadays for flight planning to define the flight path, altitude, speed of the drone system, and capturing the data to the required specifications. So, the flight planning is very important whether our area is small or area is large. Then the next terminology is the autonomous flight. As the name itself is suggesting, the flight of the drone is controlled by the internal programming. So, we have the software where the movement of the aircraft will be controlled by the program. So, it will tell the drone system where it is to fly without sending radio signal by the human, without having a control from the ground using the controller by the human being. For example, a drone may use its onboard GPS systems because this system would help to fly the drone to the predetermined points. So, we know the coordinates of those points, and these coordinates are fed into the system, the programs, and the drone system will actually use these coordinates and fly to those areas autonomously and safely. Now, another terminology is airborne collision avoidance system. Now, this is also very important because sometimes what happens is, many times what happens is that if you do not have this system, the drone system may collide with any of the flying object and damage may take place. So, in most of the drone now this is available. In drone it is called the detect and avoid technology, DAA technology, and this technology will enable the aircraft or drone system to sense if there is something in the air, track it and maneuver away. So, it will take the decision to actually detour away from it so that it can avoid the collision from the object. So, it will suspect some object, sense the object, track it and will decide to take a detour, to just change the route. These systems are very crucial actually for autonomous safe flights, especially for operation which are conducted beyond the pilot's visual line of sight. So, this visual line of sight we will understand more little later. So, he can see in this particular diagram there are two drone system, one is here, another is there, and there is an object. When they are flying, they should not collide with each other, and also they should not collide with the object. So, the UAV A system, the drone A system is taking a detour once it is sensing. So, it is changing its path so that there is no collision between the two systems. So, this is very important feature. Waypoints. Waypoint actually is a set of coordinates. The coordinates which we have already learned, set of coordinates are with us for few points, and we want to actually define those specific points in the physical space. So, waypoints will use either the GPS coordinate or GNSS technology to create the flight path of the drone. That means we want that the drone should actually collect the data, should pass through these points and collect the data. So, you can see in this picture here we have few points, okay, where the coordinates are known for these points and these is making a traverse. So, we want the drone system actually to necessarily pass through those points and collect the data along that line. So, that is called the waypoint. So, the coordinates of these points should be known to us in order to fly the drone to this. So, waypoint navigation is another terminology. Waypoint will allow the drone to fly on its own to its flying destination or the points, pre-planned or configured in the navigational software. So, if we know the coordinates of those points, we can put it in the navigational software, and they are very, very useful, particularly designing the autonomous mission for the drone. So, it will actually know its starting point and it knows how to move and it knows what is the end point of that. So, mapping would be impossible without defining these physical locations. So, waypoints are also playing important role for navigating the drone, and particularly if it is the autonomous small drone. Then we have the some authority in each country which is defining its laws and regulations for flying the drone, collecting the data and utilization of the drone. So, in India for example, we have Directorate of Civil Aviation, Federal Aviation Agency in US. So, we have DGCA in India, and this is a regulating body in the field of civil aviation, which is primarily dealing with the safety. So, you fly it, any aircraft or drone system safely in the sky. So, they have devised certain rules, drone 2021 rules, and one has to follow those rules and take the permission before flying to the area, except nano kind of a drones, their permission may not be required. So, all flights must follow actually no permission, no takeoff. If there is no permission, no takeoff, NP and NT, except the nano drones or except where permission has already been taken. Then we have another terminology which is called point of interest. It is also known as the region of interest. So, it is a spot that the drone must necessarily collect the data of that point. So, we have to define the coordinates of that point. This is called point of interest. Then we have line of sight. Line of sight, the name itself is suggesting what we are talking in this. The drone must be in direct line of sight to the person. So, using the controlling device, so that radio signals can be transmitted back and forth from controlling device to the drone and from drone to the controlling device. It should be clear and unobstructed path, that is called line of sight when we are flying the drone. Then there are terminology called visual line of sight. Visual line of sight, it is the operation of the drone within the pilot's line of sight at all times. So, we must be able to see the drone at all the time when we are flying without the aid of any device. We should not use some binocular or any other device. That defines the VLOS, what we can see from our own eye. Then there is a terminology which is called beyond visible line of sight. So, the ability to operate the drone beyond the pilot line of sight is called BVLOS, and this basically requires a special permit if you are flying the drone beyond visual line of sight. So, from the regulating authority of your country, you can take the permission to fly the drone beyond visual line of sight. For example, the controlling authority could be Federal Aviation Administration in US, DGCA in India, as I told you. So, you have to look at the rules and regulation of that country. Then there is a terminology which is called extended visual line of sight, EVLOS. It is the flight from 500-meter range to a distance at which the drone is still within the pilot's sight. It allows remote pilot to extend the proximity of the drone beyond the direct vision. So, we can extend the proximity beyond the direct vision. This is called extended visual line of sight. So, name itself is actually giving the meaning, but if you look at this particular diagram, we probably understand it more. So, the line of sight is within that circle, the pilot is flying the drone and drone is within that circle, that a particular dimension is called the line of sight here, and this is the beyond visual line of sight. We have to take the permission for that, and this is the extended line of sight, okay, which is again beyond the line of sight. Then there is a terminology which is we call as the automatic takeoff, and another terminology is automatic landing. I think the name itself is suggesting what we are doing here. In one case, it is done with the predefined height. We know the height of the aircraft, and with the predefined height, runway alignment, the coordinates are also given during the automated takeoff. We define the coordinates of the two waypoints, straight line of the runway, which can be surveyed by a navigation system. Takeoff sites are defined either inside or outside the mission area. So, for large areas, the takeoff sites are located normally in the middle of the area. Now, similarly, we define the automated landing. Now, it is done with the predefined speed. Automated takeoff with the predetermined height, but this automated landing with the predefined speed. This automatic landing is initiated from a circuit after passing the waypoints to the system. Landing sites again must be defined by these waypoints either inside the mission area in which we are flying or outside, but for larger sites we ensure that this is somewhere in the middle of the site. Then geofencing is a new terminology, is another terminology. The geofencing technology is used to create a virtual boundary, geographical boundary of an area, enable the software to trigger a response when the drone flies within that particular area. It is called georeferencing. For example, there are certain sites where the drone cannot enter into those sites, so geofencing those sites so that the drone does not enter, for example, the vicinity of the aircraft or the government buildings. Then there is a terminology which is called position hold. It is an automatic position control in the drone using barometric or the ground sensor. It is mainly used for inspection or fly to the area where it is not safe to land the drone, for example, a city area or the forest area. So, we can hold the position if we want to inspect the area also. This is the example of the geofencing which is shown here, that we want drone not to fly or not to enter into the area of the aerodrome. Then return to home is another function. When a drone automatically returns to the point of takeoff, or when the operator triggers the functions on the remote control to return home, or if the battery is low or signal from the transmitter is lost, then the drone system will return to the starting point very safely. Then there is a failsafe terminology, system that helps the protecting the drone in case of some error. In case the communication is lost and something happens, the drone lost control of signal. So, fail-safe will ensure the drone will return to the home point. Then no flying zone. Name suggests itself that there are some areas where flying a drone is restricted by the government regulations. So, there could be regions like airport, there could be very government building strategic areas where drone could interfere with an aeroplane or record sensitive information. So, we are declaring that as the no flying zone, as you can see in the picture diagram also here. These are some of the suggested readings for further enhancing the knowledge in this area. Thank you so much.